Let's take a look at this chain rule, product rule, exponential, logarithmic derivatives homework. So if we look at number one here, we are looking to do the product rule. We've also got a chain rule going on with that e to the 2x. So let's tread lightly when we do the derivative here. Remember, product rule tells us we're going to do the first, which in this case is x cubed, times the derivative of the second. Now the derivative of e to the 2x would be 2e to the 2x. Think about the chain rule there. Plus, now we'll do the second, which is e to the 2x, times the derivative of the first. And the derivative of x cubed would be 3x squared. So you can do a little bit of cleanup here by factoring out a GCF. It looks like we have an x squared in both of them. We also have an e to the 2x. So we'll put those in front. And then left, we'll have the 2 and the x in the first term. And we'll have the 3 left in the second term. All right, let's look at number 2 then. This one, we just have a chain rule. So I want you to think about the outside function being e to some power, the inside function being the negative 2x squared in the power. So the derivative here would be the e to some power times the derivative of the exponent, which the derivative of negative 2x squared would be negative 4x. So my derivative here would be negative 4x e to the negative 2x squared. Okay, keeping going here with number 3, we have e to the x times the ln of x. This one can be a little tricky, but we're going to tread very lightly. We're going to use a chain rule. When we get to the derivative of the exponent, we're also going to use a product rule. So we'll begin with the outside function. The derivative of e to some power is same e to that some power. Then we're going to do the derivative times the derivative of the exponent. So the derivative of x ln of x would be first times the derivative of the second plus the second times the derivative of the first. And the derivative of the x would just be 1. So look, you have x times 1 over x. That means that I can clean that up just a little bit. That gives me e to the x ln of x. And then I've got 1 plus ln of x here. All right, look at number 4 then. Looks like a very good product rule. So we'll take the derivative by doing the first, which is the parentheses, times the derivative of the second, plus the second times the derivative of the first, which would be 4x. Now, if you want to go ahead and distribute that e to the x, I think that's probably wise. And then you can see that they all have an e to the x. I probably would go ahead and factor that out so that you get this nice parentheses. Okay, now let's look at number 5 here. Again, a good chain rule. I've got the ln of something as my outside function, and then I've got this e to the 2x plus 1 on the inside. So let's do the derivative of the outside function first. The derivative of ln would be 1 over whatever is inside, which in this case would be the e to the 2x plus 1, times the derivative of the inside. So the derivative of e to the 2x plus 1, again, another chain. So I've got e to the 2x, and then I've got times 2, because the derivative of 2x in the exponent would be 2. Let's go ahead and make that one fraction by putting the 2e to the 2x in the numerator and leaving my e to the 2x plus 1 in the denominator there. All right, let's look at number 6 here. I've got the ln of 3 minus 2x. So the derivative would be outside function being ln. So the derivative would be 1 over 3 minus 2x. and then times the derivative of the 3 minus 2x, which would be negative 2. So I've got my derivative equals, we'll go ahead and put the negative 2 on the top. And just because I know AP can kind of make things look different in the answer choices, I'm going to take that negative from the top to make that a positive 2. And then I'm going to distribute that negative to the bottom. Look at what that's going to look like. Ooh, we've got to be ready to do that with our multiple choice questions that we see on the AP exam, because we've got to be able to make our answers fit the answer choices. Okay, let's look then at number 7. Now remember with this one, you probably can do a little algebra first. I would rewrite that ln as 5x minus 2 to the 1/2. We know that exponents in logarithms can become coefficients. So we can actually make the calculus part here a little bit easier. Now let's take the derivative. So I've got 1/2 times the derivative of ln of something would be 1 over whatever that something is, times, and the derivative of 5x minus 2 would be 5. So when I clean that up, that's a 5 on the outside and 2, and then make sure you put a parentheses around the 5x minus 2 for your derivative. Okay, number 8 here, we've got a good product rule going on. So let's do the first, which would be x squared, derivative of the second. So the derivative of e to the 4x would be e to the 4x times the derivative of 4x, which is 4, plus the second times the derivative of the x squared, which would be 2x. Clean it up just a little bit, making it look a little bit more orderly, and then we can easily see our GCF. Now, I get a lot of questions about, do I need to pull out that GCF? No, technically you don't have to. However, you want to get in the habit so that you can be prepared if it needs it. No, and when it needs it would be to fit to an answer choice that's multiple choice. So it looks like they have a 2 and an x and that e to the 4x. So that leaves me with 2x plus 1. All right, number 9 then, we've got quotient rule going on here. So remember our quotient rule is the bottom, which is x minus 1, times the derivative of the top. The derivative of ln of x is 1 over x, minus the top, which is ln of x, times the derivative of the bottom, which in this case would be 1, all over x minus 2 squared. Now this one gets a little tricky because we've got this complex fraction, meaning we've got a fraction within a fraction. Well, let me show you how I deal with that. I like to go ahead and make clear that fraction, that smaller fraction there. Okay, so what I'm going to do is I'm going to multiply by x. I'm going to multiply by that denominator. I want you to notice that I multiplied by every term in the numerator and I multiplied by every term in the denominator. So the x's cancel there. That leaves me with my derivative being x minus 2 minus x ln of x over x times x minus 2 squared. That's my derivative here. Okay, be prepared to simplify, to make to do the algebra, to be able to clean up, so to speak, your answers there. Okay, look at number 10. Again, I've got a quotient rule going on. So I'm doing the denominator times the derivative of the numerator. So the derivative there would be e to the 2x times 2 minus the top times the derivative of the bottom. So the derivative of x cubed would be 3x squared, all over x cubed squared. All right, let's clean up the numerator. I've got 2x cubed e to the 2x minus 3x squared e to the 2x over, and then power to a power, we multiply those exponents, giving me x to the 6th. Go ahead and factor here. It looks like I have an x squared in common and an e to the 2x. That leaves me with 2x minus 3 and still divided by x to the 6th. So now I can get two of those x's to cancel. So I've got e to the 2x times 2x minus 3 over x to the 4th. Okay. Sometimes the calculus is the easy part, right? And the actual simplifying is where we tend to have a little bit more trouble. That's totally normal, but you're going to have to work through that. And so that when you're on the AP exam, it's pretty easy for you by that time. Let's look at the last problem here, and that's number 11. We're asked to find the equation of the tangent line. So, of course, we're going to need the derivative. Looks like a good quotient rule going on here. So I've got low d high, derivative of the ln of x is 1 over x, minus high d low, derivative of 4x would be 4, all over low squared. And that cleans up. Notice my x's cancel here, giving me 4 minus 4 ln of x over 16x squared. Now that finds the derivative, and so in order to find the slope of our tangent line, we need the derivative at this point when x is 1. So I'm going to plug in 1 for x, and that gives me 4 minus 4 ln of 1 over 16 times 1 squared. So ln of 1, we remember, is 0. So in the numerator, I get 4 over 16. So that tells me that my slope of the tangent line is 1/4. Now, in addition to the slope of the tangent line, we need the point. So we're going to find the point at x equals 1 by plugging in 1 into our equation. That gives me the ln of 1 over 4 times 1. Well, we just reminded ourselves that the ln of 1 was 0. So my point is 1, 0. So let's put together my slope and my point. Y minus 0 equals 1/4 x minus 1 for the equation of my tangent line. I hope that helps with these problems. Let me know in the comments below if you would like to see more of this type or a particular concept. I'd be glad to create some more. Thanks so much, everyone. Bye-bye.